Hopefully today, part of this section I grouped in with the chapter before, so we've seen a lot of this. It has to do with the functions and the vertical line test and function notation. We've talked a little bit about that stuff already. We're going to talk a little bit more about it today. Okay? But this section is pretty short since we've already talked about some of it. Now, this chapter itself, we're only doing 3 sections, 2 of them today because we've already talked about a lot of it, which means we have a quiz over it on Friday. Okay? A quiz over what we're doing today on Friday, over this stuff, okay? Because this is all we're talking about this chapter. So these are the things we've talked about already with what a relation is. Remember, a relation is just a pairing of an input and output. So that's just things like a group of ordered pairs, like 2, 3, -1, 2. You know, I'm just making these up. -3, -5. That's a relation, right? A group of inputs we call the x's, y's we call the outputs. Okay, and then we pair them together in ordered pairs. This is a relation, a group of coordinates. The domain stands for the x values, right? Okay, the domain 2, -1, through -3, that's the x values. The range is the y values. Remember, that was vocab on that first test you guys took. Okay, talking about domain and range. And then we had a function. That was also vocab. It said every x value has exactly one y value. For every x, there's exactly one y. For every input, there's one output. Okay, this is what we've talked about before. We're going to continue talking about that a little bit today. The things we haven't talked about, the 2 things are called an inverse and a mapping. Okay, what an inverse is it's just switching the coordinates of an ordered pair. So, for example, if I said, what's the inverse of the coordinate 1, 2, you would say, it's 2, 1. Okay? So the inverse is when you just switch the order pair. The x's become the y's become the x's. Okay? So that one's pretty straightforward. The mapping, okay, a mapping is the way to show how every x goes to every y, or every part of the domain goes to every part of the range. And what I'm going to show is how to do a mapping in a second. It's actually really easy. It's just an easy way to tell us, is this a function or not? Okay? Rather than graph it or rather than use a table. So, for example, on the quiz, I can guarantee you the first problem will look just like this almost. Okay, we'll have a relation here. This is a group of points. Okay, this is a relation, and it wants me to do several things. Tell me the domain, the range, the inverse, and then write the mapping, and then tell me is it a function. So I have to do several things here. Okay. First, let's just take it one step at a time. It says identify the domain. Is the domain the x values or the y values? The x values. So the domain is 5, -3, 3, I don't need to put parentheses, and -1. I just listed all the x values. Now, one thing is we don't list them twice. If there happen to be 2 5s, we would only list the 5 ones. And we'll see that in just a second. I don't care if they're ordered in least from greatest. It makes it nice, but it doesn't matter. You don't have to do that. Okay, that's the domain. The range stands for all the what? Y's. -2, -4, 3, and -1. Because remember, in an ordered pair, it's always x then y. Okay. So there's the domain. There's the range. Now it says find the inverse. So the inverse I get by going through and just switching all these ordered pairs. This one is going to be -2, 5. -4, -3. 3, 3 is its own inverse, and -1, -1 is its own inverse, because when you switch it, it's the same thing. Domains, range, inverse. Then it says represent the relation using a mapping. Now, mapping is just an easy way to list this information to see if it's a function or not. Most often, when you see a mapping, when you see the ones in the book, they have 2 like ovals kind of side by side, and the first one is the x values, and the second one is the y values. So I'm going to go through and list the x values here. 5, or the domain. 5, -3, 3, -1. And I'll go through and list the y values here. -2, -4, 3, -1. And what you do is you just draw an arrow from the input to the output. So like when I input 5, the y value is -2. So that goes from here to here. That one goes from here to here. Here to here. And this one's pretty easy. Okay. Is the coordinate they're paired with is just straight across from. This is called a mapping. Now, the reason this looks pretty simple, right, and it is simple, But the reason this is helpful is because it helps us tell if it's a function or not just by looking at this. Remember the definition of a function says for every x, you can only have one output. So does every x only go to one y value in this case? Yeah, every x only goes to one y. So it says, is this a function? You would say yes, because every x goes to one y. All right? This x goes to one y. This x goes to one y. Now I'm going to show you another one where it doesn't exactly happen like this. But that answers all of this question. I said the domain, the range, the inverse, the mapping, and is this a function? Yes. Okay, so that's what you're looking to do in these. Let's look at one more here. First, identify the domain. Domain's all the x's, -5, 4, 3, -1. Range, all the y's, 4, -5, -2. Again, I don't have to list -5 again because I've already listed it as part of the range. Right? Inverse, I just switched the ordered pairs. 4, -5, -5, 4, -2, 3, and -5, -1. So there's the domain, the range, the inverse. I need the mapping, and then tell me is it a function. So on the mapping again, most often you just see two ovals. I'll list the domain, the range. Again, since I have two -5s in the range, I don't list it more than once. And then I just draw an arrow from -5, and the first coordinate goes to 4. 4 goes to -5. 3 goes to -2, and -1 goes to -5. So we see two of them go to -5. Now the question is this a function? Remember, the function is every x goes to only one y. So does all of these x's go to only one y?
No.
Well, one of them, they go to the same y, but each of these x's only goes to one y. This actually would be a function. Now let me give you an example of one that wouldn't. Let's say I added on the coordinate 4, or I'll take this back. Let's say I added 2, 4 on there. So let's say I put a 2 here. Sorry, no, I take that back. I'm going to change my mind. 4, -2. That's my coordinate. Okay. So then, let's say I would have to draw an arrow from here to here. This one would not be a function because this 4 goes to two different y values. See that? It goes to -5 and it goes to -2. So in this case, if you added this point, this is not a function. But our original one with this is a function. Even though they go to the same y value, each of these x's only goes to 1. So if you ever have two arrows coming off an x value, it's not a function. So that's an easy way to tell with the mapping on that. Last one here, if you want to use a sheet of my scratch paper, you can. I want you to do that to this problem to make sure we're all on the same page. If you want to use my scratch paper, it's up there under the TV. I want you to give me the domain, range, inverse. I want you to give me the mapping and then tell me is it a function. That way make sure, this is the last one we're going to do of this type. I want you to do those things just to make sure we're all on the same page. So again, that was the answer for those. With the mapping, you'll list the domain here. You'll list the range here. 4 goes to -2. 5 goes to +2. 4 goes to 5. And -4 goes to 1. So you get those things, then you tell me is it a function or not. Is this one a function? No, this one is not a function because of this right here. This x value has two different outputs. One output is -2, one output is 5. So this would be not a function because of that. Okay. Again, that's how the mapping helps us. It's pretty easy to see from the mapping this isn't a function because an x goes to two different y's. Yes, question? The one we did before had this case. Had, let's say it had something like this, and it had like a number, this goes here, it had like 3, and 3 went to here. it went to the same y value. That's okay because each of these still only goes to one y value. What can't happen is it goes to two different y values. See how this goes to two different y values and the other one before? They went to the same y value, but they still went to 1. This one goes to two different y values, so that's not a function. Now the reason is, if you graph these points, if you graph 4, -2, like I'll just sketch a real quick graph. If I went to 4, -2, that's somewhere down here. And then if I went to 4, 5, that's somewhere up here. What was that test we used when we had a graph to tell if it was a function or not? Do you remember that? Vertical line test. Remember, if you graph the function and a vertical line goes through two different points, not a function. That's doing the same thing, right? The vertical line test is doing the same thing as a mapping. It's telling us, does each x value have two different y values? Okay? And in this case, it does, right? This x value of 4 has two different y values. If I drew a vertical line through that, it touched it twice. So it's not a function. Okay? So that's the first thing we need to know here. Also, in the homework, it asks for it in a table. I don't care how you draw your table. A lot of people just do like the T-chart and list it like that. Some people list it like this. It's the same thing, right? 1, 2 would be the same thing as 1, 2. And then in a mapping would look like 1, 2. Okay? So when you see it as a table, it's the same thing. It's just a different way to graph the information. Okay? This table goes that way. Most people do the T-chart table. Whatever one makes sense to you is fine. Okay. Now, we need to talk about this again briefly because this didn't go so hot on our first test with the function notation, the f parenthesis x. Remember? Now, I know these are written side by side like it looks like multiplication, okay? But this is not f times x. This is just one you have to know that when you see an f and you see an x in math, it doesn't mean f times x. It means f at x or f of x. It stands for the function at x equals something, okay? Also, we can interchange the f of x is the same thing as y. That's our output. Okay, we're going to look at some more examples of these because we talked about this at the end of chapter 1. But this is f at x or f of x, not f times x. You never have to do anything with this part of the problem. Okay, so like for example, f of 5 or f at 5 means the function at 5 equals something. Okay, that's called function notation. And then also to recap, we had the vertical line test. Remember, we had a graph of a function. If you could draw a vertical line and only touch one place, it is a function. If you had a vertical line and it touched twice, it's not a function. Because like in that second example, this x value of 2 has two different y coordinates. It has a y coordinate of 2 and a y coordinate of -2. That's why that's not a function. Okay? Now, and we've seen the vertical line test before. We talked about that earlier. Now, these are the last two I want to go over with these function notation. This stands for the function at x is equal to -4 minus 2x. This part's my function, -4 minus 2x. And then I say evaluate the function for when the function at x is equal to -1. I just replace that x, since it's in parentheses, I replace it with this -1 that's in parentheses. So it's the function at -1 equals, and then anywhere I see an x, I plug in a -1 in parentheses. -4 minus 2 times -1. And a lot of people did this right on the first test we took, but then they started like messing with this side. This just stands for the function at -1. You don't have to do anything over here. All you have to do is simplify this side. So I have subtraction, I have multiplication. I have to do the multiplication first. I treat that like a -2 times a -1 is a +2. And then -4 plus 2 is a positive or a -2. So the answer, the function at -1 is equal to -2. Again, I only have to mess with this right side. The left side just stands for the function at -1. You don't do anything with that. Yes, question?
So that -4 and -2 would be -6?
Well, I can't do that first because I have multiplication here. And order of operations says I have to do multiplication before the subtraction, right? Good question. But yes, that I have to do this multiplication first because I have to do multiplication before I do subtraction. Okay. Let's look at, I think, two more of these here. Now, this is the function g of x. Sometimes instead of seeing the variable f, you see g. It's the same thing. It's just saying the function g at x is equal to this. So it says, what is the function g equal when x is 0, or the function at x is 0? So I say g of 0 is equal to 0 squared minus 1. Well, 0 squared is 0, and 0 minus 1, negative 1. So the answer to this problem, the function at 0 is equal to negative 1. Again, don't mess with this left side. It's just the function g of x equals, it's just a notation. It's called function notation. There's no other mathematical thing you have to do to it. All right, and that's all we have for today.